In matter of fact, general relativity is
So you think
literally
general relativity
trying to
is
explain relative
unbalanced
density
force?
disequilibrium, but in a mathematical base in Narnia. Do you get that?
You sure about that? There's zero centrifugal force at the pole compared to maximum centrifugal force at the equator.
Maximum centrifugal force at the equator would be about 0.3.
Okay, well, that has to, but it has to be relative to something.
No, it doesn't.
So that's not relative. So my point is this: if the gravity that is holding you to the spinning Earth at the equator is supposedly uniform based on the supposed tenets of gravity, how can that same gravity then also be not crushing you if you are at one of the poles where the centrifugal force is zero?
What the fuck did you just say?
It debunks the globe on its face. And if you think about it, you'll understand what I'm talking about.
You serious?
It's 9.8 meters per second. That's the acceleration due to gravity.
Right. That's what they're claiming. So if that 9.8 meters per second, which you're claiming is a force, if that force is enough to offset the centrifugal force at the equator, that same gravitational force would crush you at the pole.
I noticed Del never mentions why it is the egg went up when a variation in density was caused. You know, like by manipulating that density, Del, an acceleration was caused. You never seem to mention that. You always seem to talk away from that. Wonder why that might be.
Because he's dishonest. Notice how he lies to everyone and says none of us want to actually converse about this. But I think I've tried to talk to him about it 2 or 3 times already, and then I get blocked while I'm trying to talk, or he gets triggered and swears me off and then kicks me off.
Yeah.
But I don't want to talk about it, no. But I go to his channel. That's why I've just ignored the bloke. The guy's got nothing. He's literally just clutching at straws.
I wonder. Well, if you gravity causes things to have weight.
No,
it doesn't.
No,
Gravity causes things to appear to acceleration from an observer many millions of miles away. That's its definition today.
Nope.
We can definitely see that mass attracts mass with the Cavendish experiment.
Oh, wow.
No.
Well, we can observe it. So, yeah.
Well, that was I've seen the Cavendish experiment.
If that was true, it would debunk Einstein, and Einstein's theory would never have even existed because there would be no need for it to exist because the Cavendish experiment would demonstrate that Einstein was wrong.
The Cavendish experiment is basically the curvature of space-time, according to Einstein. We can see that one mass curves the space-time, drawing the other mass into it, which is how relativity would describe it. But F equals ma, or Newton would describe it as just one mass pulling on the other.
That's not how it would be described in Einsteinian. Let me correct you. Bear with me, gents. If Einstein's interpretation was to be transposed into the Cavendish experiment, what it would be perceived as from an observer from millions and millions and millions of miles away will be that the balls would appear to be attracted towards each other. But that wouldn't be an actual acceleration. It would be an apparent acceleration caused by the lensing of the medium between the observer and the balls warping because of mass.
Do you want me to
be perceived as an acceleration from one observer of an object not actually accelerating.
Do you want me to use Einstein from now on then?
No,
You'd
I
be
just
better
wanted to
off
acknowledge
sticking.
that only the observer from miles away would observe an apparent acceleration when there was no actual acceleration to be observed. He would only perceive that acceleration, that apparent acceleration, because the medium between him and the object that he's looking at, the Cavendish balls, would be moving, squashing, like affected by space-time curving by the mass. That's all. It's only from his perspective would that be the case. So no, a Cavendish experiment is claimed to be actual acceleration. That's not comparable with Einstein. You've got it wrong, I'm afraid.